One of the things that's important to understand about the Linux scheduling operations and how it works is this concept of niceness between processes. Niceness impacts how much time or how important a process is to actually get the scheduler when it is ready. You can think about this as basically being some way that a process can say, I would like others to have the opportunity to run if I'm not running directly. So, our goal is we want to understand essentially what this concept of nice is, how it manifests itself inside of our Linux scheduler. We're going to talk about how niceness impacts scheduling, the purpose for a tool called Htop, which basically shows us information about what's going on in the system, a slightly related tool called Htop, and we're going to talk about how changing the niceness can occur during the operation of a program. So to begin with, let's look at our application that we're going to be demonstrating this with. What I have here is a program that calculates pi. It's going to print pi out using the Gregory Leibniz sequence series expansion approach. This is not the greatest approach for calculating pi, so it's being done, for example, not necessarily for accuracy of pi. So we calculate that out. We're going to figure out the error, and we're going to figure out the percent error, then print it out to the console. So we've got a loop inside of here, so we're going to be looping through up to n terms, where n is the number of terms passed in, and alternating back and forth, adding and subtracting values, some things like that, multiplying to get our final result. A little bit of a time-intensive, computationally intensive program. If I run this, we see that over on the left, this is how many terms, this is our estimate for pi, this is our error, and this is our percent error. So you can see that when we're at, we're approaching 50,000 terms here, percent error starts to get pretty small pretty quickly. So what we want to do is look at how we can impact scheduling and change things with this. Now, I've got one instance running right now. I'm going to abort this instance, and I'm going to close out of Eclipse for right now so that it doesn't get in the way of things. And what I have in here is I've got a little script. So the script that I have, if I type it in right, what it's going to do is it is going to start up two instances of this program running in two different terminal windows. So that's all the script is going to do. Now we have two computations of pi going on, and I'm going to show you the top and Htop tools a little bit using this as a baseline. So let's start this script running. Close, drag that away, and dot slash run sim.sh like so. So we're going to start this running, and we see I have two windows here, running away, calculating pi. And this is probably blinking pretty quickly, but both of them are up somewhere in the mid 30,000 terms as far as computationally. If I look at my process listing, like so, whoops, ps minus aux, like so, we can see that they're both running 7308, 7309. Those are our two processes that are doing these computations. Now, if I wanted to see what was going on, there's a tool called Htop available to me. So Htop basically displays information about Linux processes. Gives me a keyword dynamic real-time running view of a system. So if I just run Htop, we can see right now that my Pi nice demos, both of these two are 28, 29, somewhere in that range, roughly using between the two of them more than 50% of the CPU horsepower just printing out and estimating these pies. Now, this tool gives us a lot of information. One of the things that's nice is this niceness index over here. Niceness has to do with how nice processes are to others. And we can either be nice in a positive way or a negative way. Both of these are right now set to 0, which is the default value. Keep that in mind. We're going to come back to that in just a moment. So this is, again, listing all of our processes. We can see that the bulk of things are going on in basically a couple of processes. Now, there is a variant of this that I could get called Htop. Htop gives me a graphical view of this, and we can see what's going on with our programs. What I like about Htop is Htop allows me to filter. So I can filter here, for example. I only want to see things that are related to PyNiceDemo. We can see them right here. Those two things are running. Again, showing the CPU utilization, we can see the number of tasks, the load average over time, the uptime for this virtual machine. A lot more detailed information that might be of some use to me as I'm looking at the operation of my system. Okay, so these are still chunking away. Let's talk a little bit about nice while they chunk away here. So, nice is a command that runs a program with a modified scheduling priority. So what it's going to do is take the process and make it either a little bit more important or a little bit less important based upon how nice we want it to be to the other processes. So we can run our command with an adjusted niceness ranging from a -20, which is very favorable. You think about negative niceness as being mean to the other processes, and 19 being least favorable. We are being the most nice. We're being the most gracious to our other processes. So this command, if we throw this on the front, is going to impact how much CPU utilization each process gets. So that being said, what I have done is I have another script here set up that I want to run. And let me get rid of these two terminals here, and you'll see in the Htop view, everything goes away. What these two programs are going to do now is I'm going to have one that's going to run with a niceness of 19. We're going to sleep for 1 second, and then I'm going to start a second process up running with -19. So this first process is being very gracious. The second process is being very mean in terms of scheduling by taking the niceness value and really setting it to value saying, I'm greedy, I want to take over as much processing as I can. So those two processes will run, and we're going to look at both how they run as far as from a CPU utilization standpoint and also how they run as far as actually getting their work done. Because remember, what we want is real work getting done with these programs, even if in our case it's kind of a fictitious, fuzzy calculation. So let's take a look at what that does. I'm going to run this script, /runsim2.sh, like so. And if all goes well, we should see two windows here. So I'll drag these. Actually, I can put them over here like so. And drag the other one up here like so. So they're both on the screen, both visible. Now what we see is this one over here on the left is at basically going to 4,000 terms in the sequence. It's very early in its execution sequence right now. This other one is up to 80,000. This one over here on the right is getting a lot more processing time because that was the second one that started. That one had the meaner value of niceness associated with it. Drag that over there. If we look over here at our processing, we can see this top process, which is this one here on the right, is getting 36% of our CPU time. The other one is basically getting 0, 1%, very low. That's why this guy is at only 9,000, because they're running very, 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 very low process-wise, or importance-wise from a niceness standpoint. There is a command called Reice. Reice alters the priority of running processes. So what we can do is set up the new priority and list it for a given process and adjust it accordingly. So I can take and have a program running, change my processes like so. So I can change all of these things. And if I do that, so what I'm going to do is, for example, Reice minus n to 0, I want to change 7353. Permission denied. I probably need to do it this way. Do a sudo, like so. Now you notice this changed to 0. All of a sudden, it's running a lot more and calculating a lot more. Its priority is up a lot higher. Now I could also flip around what I had before with my other process that was running. That would be 7353 is what I changed. Minus n negative, or minus n 19 to 7355. So I'm going to set 7355 back to that niceness of 19, very low. That was, remember, the one that I'd set very high. Make that adjustment. We see the niceness goes down, and we're seeing that that process is getting much less CPU utilization. Now all of a sudden it's running much slower on this window. So I can use Reice to adjust the niceness of things as my programs are running. That's a useful capability to have within my systems. So at this point, what we've seen is the niceness value impacts scheduling. Different values of niceness will adjust whether or not a process gets CPU time. We've seen how we can adjust the niceness of a process by using the nice command or the renice command. We've also seen the usage, or at least primitive usages, of the top command, which shows us the top information about what's going on, information about the processes running in Linux in a dynamic fashion. And we've looked at Htop, which is another additional program that gives us a little bit more ability to do things, like sorting things, like finding out more information about processes. So with that, I'm going to bring this video to a conclusion here.